Question A asks us to determine the value of the standard enthalpy change for the combustion of CO at 298 Kelvin using the following information. So the question gives us a desired reaction, and it gives us two other reactions with delta H values. And to find the delta H of this, we kind of have to manipulate these two equations to end up being like this. So firstly, I see that there was only one CO in both these reactions, and I see that the CO is on the left in the desired. So to get this to the left, we have to flip the equation essentially. And if we flip the equation, that means that delta H becomes positive because it was previously a negative. So we can just rewrite that into this. And so now we have to start canceling out. And as you can see, there was one C on the reactant side and one C on the product side. So we can cancel those out. And so we can cancel out the 0.5 because 0.5 is less than 1. So that will end up being 0.502. And the CO stays because there's no other CO in the equation, and the CO2 also stays. And as you see, this is equal to that. And all we have to do to get the delta H of this is just add the two of these, and you end up getting negative 283 kilojoules per mole. So question B asks us to determine the value of the standard entropy change for the combustion of CO at 298 K. And on the sheet, it gives us a chart of all the S values, and so I just transferred it onto the screen. And so the equation you use to find the standard entropy change is delta S of products minus the delta S of the reactants. And so if you look back, you can see the CO2 is the product, and the reactants are CO and the O2. So just plug it in. So 213.7 minus the CO value, which is 197.7, plus the O2 value, 205.1. And you times this by 0.5 because the coefficient for the oxygen is 0.5, and this is all balanced. And you end up getting negative 86.55. Question C asks us to determine the free energy change for the reaction at 298 Kelvin. So to do this, we have to use the equation delta G equals delta H of the reaction minus the temperature in Kelvin times the delta S of the reaction. So if we just plug everything in, it's negative 283 kilojoules per mole, and we calculated that right here minus the temperature, and it was given to us on the sheet, and it was 298 Kelvin. Then we times that by the delta S, and in question B we calculated 86.55, and the reason we put 0.0655 is because this was in joules and not kilojoules, so we had to divide this by 1,000 to get it into joules. And after all that, we get negative 257.21 for the free energy change of the reaction. And question D asks us if the reaction is spontaneous under standard conditions at 298 Kelvin. And yes, the reaction is spontaneous because the value of the delta G of the reaction is a negative number. To be specific, it was negative 257.21.